Okay, welcome everybody to our September call for the European Community at OCP. We have quite an interesting agenda today, as we are actually joined today by Cosimo Pecchioli and Bob Brink. They will introduce the cooling environments project, and we will hear about a liquid cooling overview in Europe by Rolf. But first of all, I want to start with some updates from the European community. And at the end of the call, as we always do, we will open the floor. We will discuss some updates in preparation for the Global Summit. And hopefully we'll hear from you back to from your feedback to steer the following calls. So I'm going to start straight on with the OCP Europe updates. So first of all, I want to welcome a couple of new members actually joining this month. For the startup program, we have OpenChip. OpenChip is actually a chiplet based accelerator designer and manufacturer for based here in Barcelona. And they recently joined the startup program at OCP, and they will have a presentation in the Global Summit. And we're working with them to welcome them and to connect them with the overall OCP community. It's actually a very interesting company, and this is actually quite new, as they actually signed up yesterday. Reconex will be part of the OCP community as a full member very soon. Reconnect is one of the biggest ITAD and circularity companies in the world. So I'm looking forward to work with them to enable the circular economy market in Europe. In terms of events, we had presence this month in the German Data Center Association. Ruben was there, actually. I was actually in the Open Source Framework Conference, and at the same time, we had Jeroen and on the 360 DC Lounge. All excellent events, lots of nice and great insights. So we were quite happy to connect with the community. In terms of alliances, we've been working with the German Data Center Association to sign up a collaboration agreement with them, as with the European Data Center Association, and we are actually trying to see how we can actually fit into this huge ecosystem of small projects, small and big projects, which is the Linux Foundation. Mostly engaging with the Linux Foundation European side. This is going to be a long process, but it's going to, in the end, it's going to be beneficial for both communities at all. So in terms of Benelux updates, I'm going to take this from Jeroen. We are actually seeing updates from ByteNet's data centers with acquisitions. Well, we are actually seeing the Dutch government stopping ASML, one of the most important chip manufacturers in Europe and in the world, from activities with the Chinese customers. And we have updates in terms of new data centers built out by Penta Infra and other chips factories, closing permanently in Belgium. So for France updates, Francois, do you want to step in, please?
Yeah, no worries. We had in France a very good article on DC Magazine where we basically are promoting OCP. As you understand, promoting OCP is not always easy in Europe, but we believe that through the awareness, it's a good position. We are also, in fact, preparing the Data Center World, which will be coming in November, end of November, 27th. We are now working, in fact, we had a presentation that was quite interesting at the ODC, from ODC, it's a French company that is basically doing confinement. We see, in fact, an evolution of the liquid cooled through initially a first step with the air-cooled solution. And this is kind of a transition that is happening. It really indicates the increase of the heat. And due to the fact that we cannot really change data center setup, this is a nice area. I had a lunch with McKinsey in order to basically see if McKinsey could be interested in joining OCP. And as we are seeing in Europe, a wider adoption of standards in order to build the software solution. And of course, some contact with Rapid Space that is quite active in the OCP arena in France. So, we want to engage on the marketplace. We also had a nice meeting with Carl at a new type of ODC, Carl Rabe, with a potential data center on a catamaran. So this is kind of exciting to see that there are different ways of doing other forms of data center.
Okay, thank you so much, Francois, for this. I want to follow up with a couple of reminders, even if this is very well known at the moment. We are actually gearing up for the Global Summit, and I will elaborate on this afterwards. But it's not only about the Global Summit, but getting ready for the next EMEA Regional Summit on April next year, end of April. So please visit the website the events website. Sorry, we have a nice sponsor prospectus there, and we are getting everything ready for this event that we are actually looking forward. Then, speaking about events, we will have a quite busy events plan for well, up to the end of the year. We will have presence in all of those events that you are actually seeing there. So if you are actually planning to go, and if you want to connect with us, please go ahead, reach back to us, send us an email, and if you want to suggest any other events moving forward for us to have presence in, because you find this that event could be interesting, please reach back to us as well. So with this, I pass the I pass the turn to Cosimo for him to discuss about the cooling environments project. So I want to introduce Cosimo. Cosimo has been part of the OCP community for quite a long time, and he's now working at BP Castrol. And he's actually steering the efforts with OCP at BP Castrol. So please, Cosimo, go ahead. Please let me know when you want me to pass the slide.
Yeah. Thank you, Raul. Cooling environments is, let's say, the bucket, the project at the OCP level that covers all the cooling challenges that we face at the moment. And when we talk about cooling, of course, we talk about liquid cooling, because for air cooling, there's not much that we can explore anymore. It's been around for so long and at scale. You can see here, I co-lead this project with two other people, Sean Sivapalan from NVIDIA and John Fernandez from Meta. And I think this is important because the three of us represent a pretty good, let's say, representation of the market. There's a silicon manufacturer like NVIDIA, there's an hyperscaler of sort like Meta, and there's a vendor of cooling solutions like BP Castrol. So I think it's a good mix. And if you change, so you can actually switch directly to slide 15. So the next one. So cooling environment is the most complex and largest project at the OCP level. And to be honest with you, most of that thanks to Rolf, who will actually speak after me, who did a phenomenal job in terms of the immersion project. He really is an example on how to do things. But the cooling environments includes, as we said, the immersion project, cold plate, door heat exchanger, advanced cooling facilities, and heat reuse. The concept is to have an overall look at what are the technologies that are implemented in terms of liquid cooling, and try to cover all of them, knowingly that the implementation of a new technology is a disruption and is a challenge. By nature, sometimes these in the OCP terminology, of course, these are called sub-projects, are a little silos. So there's not much communication in between different sub-projects, and this is where we try actually to facilitate a more open communication, because what we realized pretty soon is that no technology will be actually a total winner of the cooling environment. There's always going to be a hybrid solution. There's going to be a coexistence of different technologies at the data center level. And so immersion, cold plate, door heat exchanger will all coexist with air-cooled servers. And that's the reason why we have actually the other project, the advanced cooling facilities, where actually we look at more at the building and the integration of these technologies with the existing primary loop. So if you have a chiller or a tower and a water loop, or if you do not have a water loop and you want to implement a water loop for these different technologies. And the last project actually was implemented at this point 3-4 years ago, actually, was the heat reuse, because the other aspect that we realize is that most large IT companies now, they have pretty stringent environmental goals and sustainability goals, and heat reuse will inevitably be part of that path to be the level of sustainable that most of these companies want to be in 2030, 2040, 2050. And actually, heat reuse is doing a phenomenal job in showing how this can be done with real examples. To be honest with you, you are in Europe, guys. Most of them are from Europe because there's history and sensitivity. I am from Italy, of course, as you can hear from my accent originally, but I've been living in the US for 20 years. So I call myself American right now. So here in the US, the heat reuse, it's really challenging for a number of reasons. But of course, they drive the change when it comes to the other technologies. So it's always kind of a mixed bag. So if you switch slide. So as I was saying, the role of the cooling environments co-leaders is to try to harmonize the efforts among all the different projects. And again, I have to thank Rolf, because he's helping us significantly in this effort. These are the sub projects. Then there's a really large number of work streams, and we don't even have actually yet a complete list of the work streams that are inside the sub projects. So I don't know if you are familiar on how the OCP is structured, but essentially the project is the bucket that contains all the real work which happens at the sub project level. And then at the sub-project level, you can decide that you want to go deep into one specific matter, and those are the work streams. And all this is managed by the co-leaders of the sub-projects. Like, again, I'm sorry to keep calling you out, Rolf, but like Rolf. The other thing that we are doing, if you go to the next slide, there are two more things that we are doing. So the cooling environment is trying to harmonize the work inside of our project. Then the next step, of course, is to try to harmonize the work among the different projects inside of OCP. So data centers, facilities, sustainability, and rack and power, they all in a way touch the cooling environments. And so we need to work with them together. None of these topics is isolated from the other. So we all need to work together. And then the last point that actually we try to do is to collaborate with external organizations that are working in the same field to, of course, make sure that we are aligned. And I'm going to spend a few words now to talk about ASHRAE, because we are actually very active right now to try to coordinate the activities between the OCP and ASHRAE. ASHRAE is a very US-based organization that, so I don't know how familiar you are in Europe with ASHRAE, but actually has ramifications, let's say, even outside of the US. So that's the reason why we see that as a kind of a global effort. And unfortunately, historically, ASHRAE and OCP have been they overlap quite a lot. So ideally, we would not have two different organizations working on the same things, but in reality, we have them now, and it's impossible to see actually merge of these two organizations for a lot of different reasons. So, given the situation, we said, okay, let's get together and see how we can actually work together instead of compete. And this is what we have been doing. So, in short, we realize that ASHRAE has historically been very strong when it comes to the facilities aspect. So the building and the standards of the building, of the primary loop, cooling, et cetera, et cetera. OCP has been extremely strong historically when it actually comes to the equipment and the specific solutions. So one possibility that we are exploring now is that we actually work together with these two different focus, and then we collaborate with each other to put together one single like publication that encompasses everything. But this is just an example, and by all means, if you have experience and if you want to share your thoughts about this, please, it's an open discussion. The other organizations that currently we are touching, but it's not meant to be a comprehensive list. This is just an example, are organizations that work in this business, in this market with different angles, and we all contribute to the growth of this market. I was talking with a colleague yesterday. I think that the data center, it's a kind of in a unique position. If you think that a large hyperscale data center, it's an investment of about 1 billion, to give a ballpark figure. Now, a 1 billion investment in an infrastructure, we are talking about like an oil refinery. We are talking about a power plant. So we're talking about this kind of equipment, this kind of investment. And you don't hear building a new refinery. In the US, it has not happened in 30 years. Building a new power plant, it's a very rare occurrence. Data centers, they are popping up like mushrooms. So it's a very unique, explosive market where everybody is trying to put up fires every day without really thinking about the long-term implication and how to do things better, because it's so explosively, the growth is so explosive that everybody's super busy. So I think that the people in this call organizations like OCP, organizations like ASHRAE, and all the other organizations, they have the chance to actually support this growth in a manner that is more sustainable and to limit the amount of mistakes that inevitably are done when you are under the gun 100% of the time. So this is what we have been trying to do. Considering that all this is volunteer work, we all have our day job, but all things considered, I really think that we are doing a phenomenal job, and Raul and the coordination between these two different regions that represent probably one of the most important market of the world. In terms of volume, maybe Asia is actually probably ahead of us, but in terms of solution and technology, we actually lead the market. So everybody looks at what the US and Europe are doing to learn how to do things. So we are in a unique position to influence, to be honest, I mean, the global effect of what we are doing. So this is what we have been trying to do. It's a short intro. If you have questions, I have to apologize. I really have to drop it at the bottom of the hour, so I have a few minutes. But Rolf is going to be here after me, and actually he's much smarter and knows these matters better than I do. So if I can answer any question right now, more than welcome. Otherwise, Rolf will take the questions later.
Don't be too
Thank
modest,
you so much, Cosimo.
But
guys, I need to tell you something. The call is actually recorded, Cosimo. So if we have any questions that you want to pick up another time, you can actually check the recording in the YouTube channel. Excellent. And we will work with Rolf on that as well. So thank you so much, Cosimo, for your help today and for that presentation. I think that this sets the stage right to go over to Rolf with the industry insights about liquid cooling in Europe. So please, Rolf, if you want to start, you can actually start sharing your deck right now if you want.
Yep.
Should let you do that.
I just prepped it for the screen. And I'm going to start not with my own deck, just with a quick community-related call. Also in follow-up from Cosimo. He's already mentioned the immersion project quite a few times. So let me switch on my camera as well, so you guys can see me. Hi, everyone. Within the immersion project, we've gone through some serious restructuring because we need to scale beyond what the OCP project has been designed for. With the immersion community, we have over 600 participants in the community worldwide, and as part of the restructuring, we're kicking off a whole lot of new activities as well, and there is a call for participation open. There are leadership roles, volunteer leadership roles available, which if anyone is interested, or if you know somebody who would like to get deeper into the OCP community, especially on the area of immersion cooling, there are a bunch of lead roles which we have communicated to our community related to immersion fluids, IT equipment, reliability, and solutions. And these are committees that we have created recently, technical committees that we've embedded in our organizational structure. And the work stream, and there are, and we've allocated all of work streams underneath these various technical committees. If you feel that you're interested, or you know somebody who's interested, reach out. Please, you can scan the QR codes, and I'm pretty sure we'll share the deck afterwards. And if not, we'll make it available somehow to the attendees or to the rest of the European community. But reach out to the respective leaders of the projects or work streams or committees, and let it be known that you have an interest, and we would love to embed you in our immersion project. So without further ado, I'm very happy to provide the European community with some insights related to the data center industry. This is a promotion deck. I've been invited to do this presentation as promotion, so I'm really happy to be able to do that. I'll start with a very quick introduction of myself. For those who are unfamiliar with me, I'm the founder and owner of Promotion Consulting, which is the my consulting company. I'm an entrepreneur and private investor in various high-tech initiatives. One of the key areas that I focus on is global sustainability impact. Whenever I put my money into something, I want to make sure that it's related to that it will help drive sustainability impact. But as mentioned, I'm also the project lead for the immersion project. I've been part of the founding members of the structure which we currently have embedded within cooling environments, where we have all these activities that coexist for the different technologies, and where we are providing harmonization across the various cooling technologies. I'm also the founder and inventor and investor of one of the immersion companies in the market, that's Asperitas. I'm no longer involved with Asperitas. I stepped away from that a couple of years back, and I have a long background in enterprise IT and data centers, also at British Telecom and various other IT companies. And what I'm going to take you through today is just some of the highlights. First of all, I'm going to take you through some highlights that are currently, that the industry is currently working with, and I'm talking about the data center industry. And I will take you through some of the market figures relating to liquid cooling. But I'm going to start with some of the trends that relate to the data center industry, and a lot of these will be familiar to most of you. So I'm just going to touch upon them briefly so we can spend some more time on the market dynamics. Urbanization of data centers is one of the big topics, and I just noticed that there is a confidential statement here, which is, please ignore that. I'll remove that for the published presentation. Urbanization of data centers, this is where we're referring to edge data centers, smaller facilities that get closer to the end users, which are challenged by the environments that they need to operate in, right? So getting a data center into an urban environment is a challenge by itself. You have the power envelope challenges, floor space, square meters are very expensive, and you're suffering from noise nuisance. But there is an ever-increasing demand to get closer to the edge of the network, specifically due to the 5G presence across Europe, to help decrease the data processing load over the larger networks. So it is expected that we're going to see a more distributed ecosystem of facilities, of smaller facilities across the continent. And one of the main challenges across the industry as well is the ever-increasing chip densities. And this also relates to liquid cooling, which I'm going to get into in a couple of minutes. But this is an ever-increasing challenge for the data center industry. We're reaching higher and higher rack densities, which is pushing the limits of the power envelopes of the facilities. Right now, about 10 years ago, sorry, about 10 years ago, we were dealing with data centers that were struggling with their physical space. Today, the physical space is no longer a concern. The kilowatts per square meter are less and less of a concern. Right now, the real bottleneck is the power availability. It doesn't. Most of the data centers have space in abundance, but the power envelope is stretched to the limit, and that is among others caused by the ever-increasing chip power consumption. Another element that the whole industry is dealing with is the effects of global warming, right? Increasing cooling demand is a very obvious result, but some of the other aspects that are more and more challenging is when you're trying to find an appropriate site for critical facilities. You want to take into account the longer term effects of global warming, and what you're seeing around the world is more difficulty with finding appropriate sites. Overall, sustainability is becoming more and more of a focus area, where most facilities nowadays are already well embedded with green energy. Water usage of facilities is becoming a bigger concern, and the carbon footprint and accounting of within data center organizations is also becoming more prominent point of attention. And this is all stimulated by some global regulatory trends where Europe is taking a leading role. We're talking about energy consumption caps, renewable energy initiatives. This is also where the European Union is providing a lot of incentives. Water usage effectiveness, also in Europe, this is a big deal and an ever increasing concern. And with that, there are many people who tend to think of water usage being part of a liquid cooling, being a problem relating to liquid cooling. This is not the case. The water usage, the water consumption by facilities relates directly to the evaporative cooling in cooling towers, right? That's where water evaporates to help bring down the temperature in a cooling loop. And that consumes tremendous amounts of water. And this is especially a concern in the drier areas, in areas that are especially suffering from the additional heat, also related to global warming. Heat reuse initiatives, this is something that is broadly accepted in Europe. More and more facilities are actively engaging with heat reuse, and that is also stimulated by regulatory initiatives. Building location regulations and is something that is also coming more and more into the scene. If you're looking at the Amsterdam region, the Greater Amsterdam region, it's going to be difficult to plan for a data center in that area. Well, first of all, due to the power availability, but beyond that, nowadays we have some very strict rules on what kind of efficiency metrics you need to be able to adhere to when a data center becomes operational. And carbon reporting is seems to become a potential mandate, seems to become mandated in some regions as well. So having said all that, the ecosystem, the data center ecosystem is under a lot of pressure, and this is where liquid cooling provides has a significant amount of traction. Most people in the industry recognize liquid cooling technologies as a way to address most, if not all, of these challenges and trends. So without going into the details of how these technologies do this, I'm just gonna give you guys a very quick overview of these technologies, and I'm going to show you what is happening in the market with these. So starting with indirect liquid cooling, door heat exchangers. These, most of you will be familiar with these, with that technology, and it's a technology that is really penetrating the market, also thanks to the OCP adoption of door heat exchangers in the open rack designs. Direct-to-chip cooling technology is also referred to cold plates, especially within OCP, we refer to it as cold plate technology. It's a form of precision cooling. It brings liquid into the chassis directly to the hottest components. So think of the GPUs and CPUs, right? One of the challenges arising with direct-to-chip cooling or cold plate cooling is that it's really only suitable to cool very explicit hotspots that you can cover with a cooling block, with a cold plate. Then we have total liquid cooling, which is immersion cooling, where which fully exposes the electronics to the dielectric fluid because it's literally submerged inside a fluid. It's optimized for full heat removal of the system. One of the downsides here is that immersion cooling is not particularly specialized in hotspot cooling, right? Especially when we're talking about the highest density chips. These are important factors to understand because that is something I'm going to get into in 2 or 3 slides from now. But these are the main technology groups. How we're also dealing with them within Open Compute, but also how these technologies are positioned in the market. Now, if we're looking at the market traction, what we've seen in the past year is something that is incredibly exciting. For the past 20 years, we've been talking about liquid cooling in the industry. And last year, something finally happened. Both Intel and NVIDIA came out with chips that require cold plate to be run, to be operated. So up to last year, these ecosystems, these technology domains have seen an organic growth, which was not bringing them towards a commodity-style technology. However, a year since the announcements from Intel and NVIDIA, and now also the manufacturing of solutions with the latest chips, cold plate has suddenly become a requirement, and that has driven the industry to show an incredible uptake in cold plate technology that will accelerate still over the next few years. Simply because every year there's going to be more and more and more IT systems that will require cold plate technology. The immersion ecosystem is a couple of years behind on cold plate. That has always been the case, simply because the necessity of immersion technology is more focused on the entire platform. I'll get into that in the next couple of slides. But right now, the long-term outlook is that the immersion revenue part in the industry will reach similar levels as cold plate around 2030, which is a massive mark. However, the uptake is going to be extended until later in this decade. Right now, these forecasts are based on purely preliminary data, so it is not completely verified data. This is still work in progress, but I promised Raoul that I would give him the scoop for this. So here it is. So don't put this in any formal documentation yet. There's more work that I'm doing here around these forecasts, but this is what we're currently looking at in terms of outlook. And that long-term outlook is of particular interest for some of the more technological backgrounds on this. One of the things, a couple of things that I want to mention about these forecasts as well is that, hey, these are still emerging markets. Cold plate is now maturing, is becoming a mature industry. Immersion is a long way from being a mature industry. It doesn't relate to the people involved, of course, but it relates to the lack of standards, the lack of so a lot of developments that still need to take place, harmonization across the different types of technology that we haven't figured out yet. That is something that we have high on the agenda for the next couple of years. Also, something that is very difficult to include in a forecast is significant adoption events by hyperscales or other events that we may not account for, which may have a drastic impact on forecasts. One of the things that is for sure is that there is a lot of innovation that still needs to happen also in the liquid cooling domain. And this is not just for immersion cooling, also for cold plate technology. What we are facing right now is a market with significant challenges for heat management, for thermal management based on the silicon. But that is not going to be addressed with the current generation of cold plates. We're going to need better cold plates. We're going to need better approaches to manage the thermals of these chips. Regulatory effects will also have likely a positive effect on these outlooks, but there may be some negative effects. We have seen a negative effect over the past couple of years with the regulations related to PFAS and global warming potential, which directly has directly affected the two-phase immersion cooling domain. I'm not going to dive too deep into technologies, but these are things that we're also managing and working with within Open Compute. Now, what about this ongoing challenge with these chip TDPs, right? So I've shown this the trend graph in a previous slide. One of the things that I particularly want to highlight is that the CPUs are only part of an IT system. An IT system consists of many more components that consume a lot of power. Some of the main ones are the GPU, the CPU. Beyond the CPUs is the power delivery to them, right? So there are significant losses over the voltage regulators and the power delivery network, which is embedded on the main board. We're talking about network cards, we're talking about memory, storage, and the power supplies. One thing that a lot of people tend not to think about is when you scale your CPU to twice the amount to twice the performance, all these other components that are in the system will need to scale alongside it. So if you have a CPU that can do twice the workload, because it's a new CPU that's coming out, let's say 18 months from now, all the other equipment around that CPU will need to scale accordingly. You're going to have more IOs that are written and read from your storage environment. You have more interactions with your memory system. You have more network traffic that needs to be transmitted or received. For every watt of power that goes into the chip, you have more losses, and all the power consumption has to be delivered by a power supply or by a power shelf, but all those losses need to be accounted for, which means that right now we are solving some of these thermal challenges with the cold plates, but cold plates are not necessarily economically viable to implement over the entire system. Now, is this a problem for every server that we have? No, it is not. Because if we look at the entire ecosystem of systems, this is an overview of all systems that were supplied, all units that were supplied in 2023. A rough categorization of this, you cannot compare the thermal challenges of a GPU optimized system with a networking switch or a cloud optimized server, right? They're different pieces, they're different assemblies, they have different types of components, right? So these challenges relate to very specific equipment. However, over time, the type of technology used in a GPU optimized AI cluster will trickle down into the mainstream systems like for general purpose technology or cloud optimized systems. And that will also start increasing the load and increasing the challenges for those kind of systems. So what does that mean for forecasting certain adoption events or certain moments in time where different technologies will pick up? This is something that I started looking at over the past year, also inspired by the adoption event or the announcements for cold plate for Intel and NVIDIA. When all these adjacent components around the CPUs and GPUs start scaling, they're going to become more and more of a thermal challenge. And again, I've mentioned this already, it's not going to be economically viable to apply cold plates over the entire system. And this is where immersion comes in. At some point in time, in the near future, in the next couple of years, we will require immersion cooling as a technology to facilitate that overall thermal management of a system. And this is why there is so much industry attention to immersion cooling. This is why the chip ODMs and platform ODMs are participating in the immersion project, not because they need it today. It's because they know that they will need it in a few years from now. And this is something that the entire industry will be faced with. Right? With the advent of cold plate today, every facility in the world will have to deal with some kind of liquid cooling in the next 2 years. Whether it's going to be that single rack somewhere in the corner with only a single cold plate, or whether it's going to be hundreds of megawatts of data halls in a facility that will be equipped with cold plates. immersion cooling is coming alongside. Right now, we're looking at mostly pilot projects, mostly viability studies, and to prove the viability of immersion and to learn how to deal with immersion. Some of the things that need to happen is that all these technologies will require harmonization and will require a unified way of work beyond. So that's got to be a focus area also for cooling environments. But what does this mean for the outlook of the ecosystem? Now, this is again, this is also preliminary data. Do not use this as any management debriefs yet, but this is what it currently looks like as a viable trajectory. IT equipment supplied, so all new equipment that will be supplied in 2030, it is very likely that about 50% of all equipment supplied in 2030 will require some kind of direct liquid cooling approach, whether that's cold plate or immersion. 45% of all equipment supplied in 2030 will likely need to be equipped with cold plate technology. Some of that will be combined with door heat exchangers to facilitate that 100% capture of heat in the facility cooling circuit. About 30% of all equipment supplied in 2030 will likely not be able to operate in an air-cooled environment, will likely require an implementation in immersion. And this outlook gives us a milestone that we need to plan for. Right? At some point in time, whether that's 2028, 2029, or 2030, there's going to be that sudden ramp up in immersion cooling technology. It may also be 2027, right? But that ramp up is going to be caused by platform manufacturers providing new technologies which will require the operation in immersion cooling if they're going to be used effectively. And where exactly in time that event is going to happen, that is unsure. It has been unsure for cold plate for many years as well. We found ways of dealing with air a lot longer than anybody expected. But at some point, it was decided by the chip manufacturers that, hey, yeah, we can no longer do this in air. It's no longer feasible. The impacts and the complexities are now getting too big. That same thing will likely happen for immersion cooling. And with that, I'm going to conclude this presentation. And I'm going to hand over back to Raoul.
Thank you so much, Rolf. I mean, this is extremely valuable for the community. So with that, I'm going to share again my screen and actually jump up straight to the Q&A for you guys. If you have any questions.
Not all at the same time, folks.
Mm-hmm. Okay.
Rolf, thank you.
Go ahead.
Yes, but I have a question not regarding the overall, but regarding the presentation from Rolf. So the question is about the servers which are ready for immersion. I mean, from the beginning, from the scratch, they are designed for immersion. Can you give your evaluation of that? Because do we see that now on market they exist, or they growing this share, or we still need to take existing servers and adopt them for immersion?
I think that's a fantastic question. Thanks for that, David. So there are some servers that are suitable for immersion, and some manufacturers are are beginning to position that as such as well. However, the design specifically for immersion is still a couple of years out. So the servers that are deemed suitable for immersion right now by the manufacturers, they're still derived from air cooling designs. One of the inflection point that we're going to be looking out for is the moment that you have a specific challenge that you can no longer solve in air, that is only going to be solvable in immersion. And that's where a unique platform design will come into play at some point in time, right? Where you have a different product line that cannot be operated in air and can only be used in an immersion environment. We're looking at platforms that are so thermally complex. Think of platforms like the NVIDIA DGX boxes, for example, right? They have a combination of cold plate technology and air cooling technology, which is becoming ever challenging because of all those elements that need to scale along those GPUs and CPUs, right? When that reaches a level where you cannot deal with that effectively in air cooling anymore, and because we've already seen that the evolution of those DGX systems over the years, they've become bigger and bigger and bigger, simply because otherwise you can't fit the heat sinks in them, right? So as soon as that becomes the biggest problem for those platforms to facilitate appropriate AI workloads, that's when you can imagine a specific immersion-ready design to come out into the market.
Rod, but do we see any OCP servers which will be ready for immersion cooling? I mean, is it
yes,
or not?
yes. There's a few that are currently being. I think it's MyTech that is coming in with an immersion-ready server. Gigabyte has already positioned some immersion-ready servers, so there are some immersion-ready servers out there. But immersion-ready is something else than designed for.
We have a question from Erica.
Hey, Erica.
Hey, how are you?
Fantastic. Bring it on.
Okay. So I have a question. You mentioned that the thermal densities of the chips are going to require direct to chip cooling, and that's you're not going to be able to cool them enough with immersion cooling. I thought I heard you say that, but then eventually you're going to need to move everything to immersion cooling once the entire system's densities are so high. So what happens to managing the hotspots on the chips in an immersion environment? And I'm sorry, I only have 2 minutes. Yeah. I have another meeting, so I might have to follow up with you separately.
No worries. I can answer that very quickly. And I did say that. And this is part of the. There's two elements to this. First of all, it's part of the evolution of immersion technology, which we're currently already seeing. And I'm just putting this slide back on screen. One of the things that is very important to look for, which is very likely to happen, which I expect to be a major part of that ecosystem, is the combination of cold plate technology and immersion cooling, right? So especially when dealing with hotspots management, if you got cold plate in an air-cooled environment, the same cold plate can just as well be implemented inside an immersion system. Right. So right now we're seeing the first developments towards that are moving in the direction of cold plate being combined with immersion, with directed flow heat sinks. A specification is coming out through OCP any day now. We'll be voting that through in the next couple of days in the immersion project that's been contributed by Intel. That is one of the first steps in the direction of cold plate technology within immersion. But there is nothing withholding a water-cooled cold plate from an immersion environment, right? Water has twice the heat capacity compared to the immersion fluids that we're using. So it's quite likely that, especially for the higher thermal workloads, either water-cooled or two-phase cold plate technology will likely be embedded inside immersion systems to respond to the ever-increasing thermal challenges. Does that answer your question, Erica?
Yeah, it's super helpful, and I'm sorry I didn't like quite just when you were speaking, I probably should have thought of that ahead of time, but it just became
No,
I
I didn't touch upon it. I'm glad that you asked, because it allows me to explain that better. Thanks.
Awesome, thanks.
Thank you, Erika. So we are on the top of the hour now. I wanted to finish with a couple of topics here. We are looking into organizing a European track at the OCP Global Summit. So the plan is actually to do some matchmaking, to do some lightning talks for newcomers, doing some introductions to the overall European community and adoption strategy. So if you are going to be at the Global Summit, and if you are an OCP Europe member, or you are interested to join, please let us know. We want to include you into the agenda, and we will share with you the overall plan that we are actually trying to put together. And with that, I want to share with you again our usual community feedback poll that we share in every call. This is a Google form for you to provide your feedback about the call, and for you to make suggestions about upcoming topics. But from now on, as you saw by the overall topic, and as we announced in social media, we are starting a collaboration with the liquid cooling, with the cooling environments working group, and we are planning into having a deeper discussion about liquid cooling in Europe. But if you have any other suggestions, you can actually go there into this QR code or on the link that you see below to put your feedback about the call and the follow-up topics. And without further ado, I mean, we are composed right now by a team of 3 regional leads. This is going to be expanded as needed. So we didn't have Jerome today, but I want to and Ruben, but I want to thank Francois to be here today. At the same time, I want to share with you our experience centers throughout Europe. So if you want to know more about OCP, please scan this QR code and find your closest experience center to go visit and see how OCP is deployed in production. And then with that, a call to action to join the project, to do the contributions, connect at our events. And this is actually our project webpage and mailing list. So if you want to join there to be updated about the latest developments and other topics, please go ahead and join us. And with that, I want to thank you all for your attention. I think that we had a very complete call today. I want to thank you all for joining. I want to thank you, Rolf, for this very comprehensive presentation. As you mentioned, I mean, this is the recording of this call is going to be shared over our YouTube group, our YouTube channel, and the slides of this call are going to be posted in our wiki page. So all of this content will be available soon to you for your reference. And I think that given the discussion that we had today, this is going to be extremely valuable for everybody. So thank you all. I'm going to stop the recording now. So if you have anything else that you want to discuss after the call and still be here, feel free to.